This is an introductory video on the movements in the upper limb. It's going to follow a similar organization as the video on movements in the shoulder that we did previously. So I'm going to go through all of the bones and talk about the articulations and then the movements that occur at those joints. So starting off, we're going to start with the elbow. I'm going to orient this so that you can see it best, right about here. So keep in mind that at the elbow joint there are multiple articulations, it's not just one articulation. And the elbow joint is formed by the distal end of the humerus, as well as the proximal ends of the ulna and radius. And so you've gone through all these features, so very quickly and briefly I'm going to talk about what is articulating with what to form this joint. So starting off is the trochlea, which is this raised area right here on the distal end of the humerus. The trochlea is articulating with the trochlear notch of the ulna, which is this C-shaped depression here. To show that a little bit more clearly, I'm going to pull out two bones here. Here's the ulna, and this is the trochlear notch. It's articulating with the trochlea on the humerus. So you can see that pretty clearly here. In addition, we have on the back side the olecranon, sometimes also referred to as the olecranon process. And that is, when the elbow is extended, that articulates or is associated with the olecranon fossa, which is this depression on the distal end of the humerus, on the posterior aspect. So again, when the elbow is extended, the olecranon or olecranon process is articulating or inside of that olecranon fossa. So back to the anterior side, here is the capitulum, which is this rounded end on the anterior segment of the distal humerus. That articulates with the radial head, which is on the radius. And it doesn't do so very well here. There's a gap, but that's just because of the way that they have articulated these bones. But you can see sort of how that would go right there. So also on the ulna is this projection here called the coronoid process. And that coronoid process, when the elbow is flexed, so here, flex that, so you can see at some point it's going to contact the humerus. And where it does is called the coronoid fossa, which is this depression just proximal to the trochlea. So you can see that here. So again, when the elbow is flexed, those two areas of the bone articulate with one another, the coronoid process and the coronoid fossa. You have a similar situation on the radial side between the radial head and this depression just proximal to the capitulum, which is called the radial fossa. And again, when the elbow is flexed, that will articulate at that point. So that gives you a rundown of basically what's articulating here, and knowing all of those features kind of gives you a visual and a sense of how these things are moving in relation to each other. We've talked already about flexion and extension of the elbow. Those are between those joints, that is the only two movements that you can have. So flexion and extension. And do keep in mind that when we're talking about flexion at the elbow, it's referring to moving the forearm in relation to the arm. So we're moving it closer together, that's flexion. When you increase the angle between those two segments of the body, that would be extension. So moving on, we're going to go over three joints called Radioulnar joints, and based on the name you can intuit that those are between the radius and the ulna. And there are three of them, the proximal one, a distal one, and then an interosseous one. And I'm going to go through each one individually. But these three allow for pronation and supination. So first is the proximal radioulnar joint. And that is right here on the proximal ends of the radius and the ulna. And the articulation is between the radial head and what's referred to as the radial notch, which is not actually on the radius, it's on the ulna. And so let me show you, because these are hard to articulate with one another. They're already articulated, so it's hard to show. So I want to be able to pull them apart, two separate bones here. So we have the radial head, and then on the ulna, see I flipped it over, on the ulna is that little depression there, and that's called the radial notch. So radial notch, not on the radius, it's on the ulna. It's not named for the bone that it's on, it's named for the bone that is articulating there. And you can see how based on their shape that would allow rotation. See that? Rotation of the radial head in relation to the ulna. So there's also a distal articulation between the ulna and radius. So that is involving the ulnar head, which is round, just like the radial head, so you can see that here. And then there's also an ulnar notch, which is on the distal end of the radius. Again, not named for what bone it's on, but named for what articulates there. So ulnar head, ulnar notch on the radius, radial head, radial notch. And what I want you to appreciate about these two joints that I just talked about is their shapes allow for rotation of the radius in relation to the ulna. So you can see that the proximal end, and when the distal ends are articulated, you can see how that would, there might be movement and how the radius might rotate around those two ends, those two joints. So those are two of the radioulnar joints. The next one is interosseous. Pretty simple. It's just this joint here. There's some connective tissue between the two shafts. You will go over that a little bit more when you do the directed study on joints. So just again, proximal, distal, and interosseous radioulnar joints allow for pronation and supination. So what do those terms mean? I have to turn this sideways so that you get a good view of this. So when we're talking about pronation and supination, pronation is twisting the radius in relationship to the ulna. So I'm going to show you that on the bones. So the radius moves and rotates about the ulna. What that looks like on a person, so I can get a good view here. So right now I'm in anatomical position, correct? So I am supinated. But if I rotate my radius, now I am pronated. So this, if I go from this situation and pronate, I am moving my radius, and now my palm is facing away from the anterior side, and now the back of my hand is now anterior. So that is pronation. The opposite action would be supination, which would be moving the radius back into anatomical position. So one way that you can remember this is hold your hand like this. If you're holding a bowl of soup, you are supinated. If you were to try to hold a bowl of soup while you're pronated, you're going to drop the soup, right? So that doesn't work. So that's pronation, and that's supination. Next is the wrist joint, which is also referred to as the radiocarpal joint because it involves the articulation between the radius and the carpal bones. This joint is between the distal end of the radius and some of the proximal row of the carpal bones that are in the wrist. That is the simplest explanation. You'll get a little bit more explanation and more detail in your directed study on joints. But essentially, this joint allows for two pairs of movements, either flexion and extension or abduction and adduction. So let me show you what that looks like at this joint. So as similar to your elbow, you can flex and extend at the wrist. And so that is moving the hand in relation to the forearm. So this is flexion. That would be decreasing the angle between the hand and the forearm, and extension would be increasing the angle between the hand and the forearm. So again, flexion, extension. And similar to the shoulder, you can have abduction and adduction of the hand. When you're talking about this, it's always in relation to the body. And what I mean by that is this is a right upper limb, and the body would be over here. All right. So when we're talking about abduction and adduction, that is always in respect to the hand in relation to the body. So abduction is moving at the wrist, so moving the entire hand laterally. I'm having a hard time doing that because of the way this is articulated, but you can see this would be, normal anatomical position and moving it away from the body. By the way, these are color-coded. You're going to find out why in a second. But moving at the wrist and moving it laterally, away from the body. The opposite of that would be adduction, so moving at the wrist and moving the hand closer to the midline of the body. So again, abduction at the wrist, adduction at the wrist. So the next series of joints are in the hand. They're very complicated, so I'm hoping that this video helps you with that. They're hard to visualize. So if you look at the slide that's in your directed study, I have colored my hand with the same colors as are indicated on that slide. And not only does it show you on the bones, but it also shows you on an actual hand. And that's what I'm doing in this video to mirror that. And I'm hoping you can see these colors. But what I'm going to do is show you in both locations, both on the bones and then the approximate location on myself. And then once I've gone through each of those bones and what's articulating what forms the joint, I'll go over the movements for each one. So the first one is between the carpal bones and the metacarpal bones. So right in this area right here. That is called, in each one of these is a carpo metacarpal joint. Again, carpo metacarpal indicates which bones are articulating. In a person, that approximate location is indicated by this red line, both on myself and in your directed study. So in this general location is where you're going to have carpal bones articulating with metacarpal bones. From now on in your directed study, that's going to be abbreviated as CMC. You'll see that in the muscle action list. So CMC, carpometacarpal. Now, for the most part, for the 2nd through 5th digits, so the fingers, 2nd, 3rd, 4th, and 5th digits, there's not a lot of movement going on there. The majority of movement at the carpometacarpal joint is at the 1st digit, which is the thumb. So this joint is a little bit different than the remaining digits. It allows a great deal of movement relative to the others. So we'll talk about that in a second. And again, for the remainder of this, the thumb is set up a little bit differently than the fingers, so each time we go over a joint, I'll explain how it's different. So carpometacarpal, the next one is between the metacarpals and the proximal phalanges. So each one of these is a proximal phalange. It's the first one. So the joint between metacarpals and proximal phalanges is metacarpophalangeal, is what it's referred to. That is abbreviated MCP, metacarpophalangeal. That is indicated, I don't even know if you can see that, by the yellow on myself right here. Next is the proximal interphalangeal joint. That's between the proximal phalanx of each digit and the middle phalanx of each digit. Now, obviously, because the thumb does not have a middle proximal, a middle phalanx, then this joint does not exist on the thumb. It's only on digits 2 through 5. So that is referred to, again, proximal interphalangeal, abbreviated as PIP. Next is the distal interphalangeal, again, only on digits 2 through 5. That is between the middle phalanx of each digit and the distal phalanx of each digit. So that joint is right here on each of these digits. That is indicated as green on myself, and it's the last interphalangeal joint, the one that's most distal, hence distal interphalangeal. Now the thumb, because it only has a proximal and a distal phalanx, so proximal, distal phalanx, there are no two joints there, so that gets a separate name. That's only referred to as interphalangeal because there isn't a proximal or a distal. So you can abbreviate that as IP, and that is indicated by orange on myself here, and on the bone it's right here. Let's move on to the movements at these joints. Starting with the carpometacarpal joint, or the CMC joint, and the thumb. It's quite complicated, and you'll see different terms used for different movements there, but we're going to simplify it. We're going to go over 3 pairs of movements. First is flexion and extension, and then abduction, adduction, and then opposition and reposition. So those are all the movements that can occur there. So again, that is at this joint right here between the metacarpal and carpal. We'll go over more of that in the directed study on joints. But flexion and extension occurs similarly as it would at any other joint that we've already talked about. So at moving just this joint, I've flexed my thumb and moved it closer to my forearm when I do this. Notice how I'm not moving the joints that are more distal on the thumb. I'm only moving this joint right here, the CMC. So this would be flexion, moving the digit closer to my forearm, and this would be extension, moving it further away from the forearm. So flexion at the CMC joint, extension, CMC joint. And so also at that joint, I'll show you here actually, that occurs where you can see it in the bone, flexion and extension. Flexion, extension. You can also abduct and adduct at that joint. So it's very similar to at the wrist in the same direction. So I'm going to do only at this joint, try not to move the rest of my thumb. So abduction, adduction. So moving the thumb away from the hand, moving it closer to the hand. You can also do opposition and reposition, and this is actually a combination of a series of different movements. But basically, anytime if you put your fingertips together, so you move your thumb closer to your fingertips so that you can make an OK sign with any one of your fingertips, that movement is called opposition. So I'm opposing my thumb, and but to do that I have to flex and I also have to rotate at this joint right here. Right, so that's opposition of the thumb, reposition of the thumb. I'm going to show you that in the bones in something that's a little bit more mobile. Got a lot more movement in this one. So opposition, reposition. And you can also, I'll show you abduction, adduction on this one too. So abduction, abduction, adduction. Adduction. See, ab, add. All right, that gives you a visual. All right, moving on, we're going to talk about the MCP joint, the Metacarpophalangeal joints. Put this down here. All right, so these are yellow. You can see them here. And at this joint, we have flexion, extension, and abduction and adduction. So what I'm going to do is show you in my digits first before I do it in my thumb. So I am flexing only at the MCP joints, Metacarpophalangeal. Notice how the other interphalangeal joints that are more distal are not bending at all. So let me turn it to the side so you can see that. So again, these joints are not moving. I'm flexing at the MCP joint right here. All right, ignore my thumb. So these joints are still extended here. So this would be flexing the MCP joints of my digits, and this would be extending the MCP joints. You can also do that in the thumb, only at this joint right here. So I'm going to try to move that without moving anything else. So flexion and extension at the thumb MCP joint. Let me show you that here, if it'll allow me. Let me get my mobile one. So again, MCP joint right here, flex, extend. You can also abduct and adduct at that joint. So show you that a little bit on this side. It's kind of hard. It's not as obvious as other abduction and adduction, but you can see I'm just moving that joint right there as best I can. So abduction and adduction at the MCP joint of the thumb. And in the fingers, what that looks like is it's a little bit different, so we have to kind of redefine it. So imagine a midline right through the palm, and so abduction at the fingers is spreading the fingers away, those digits away from the midline. So this is abduction of the MCP joints of digits 2 through 5, and this is adduction of the MCP joints at digits 2 through 5. So it's not in relation to the body, it's in relation to a midline of the palm. It's a little bit different definition. You can see that here. You can see how those proximal phalanges can rotate around those joints and spread. So we can abduct and adduct at those joints. Okay, moving on to the proximal interphalangeal or PIP joints. Those are blue on myself. So it gets very difficult to only flex those joints. By the way, we'll talk about why in the future, but I can barely do it without also flexing the distal interphalangeal joints, but I'll do my best. Again, I only have this in digits 2 through 5, not the thumb, but I am flexing at only that joint right there. I'll do it from the side. Do this. Yeah, I'll do my best. So notice how MCP is still extended, but I have now bent at this knuckle. So that is the proximal interphalangeal joint, or the PIP joint. And we can do that here as well. So again, proximal phalanx, middle phalanx, so it's between those two joints, and I can flex and extend at that joint as well. Now, with those, the pip and the dip joints, it only allows flexion and extension. You cannot abduct at those joints, and that's due to the strength of the ligaments, and again, we'll talk about that with the joint directed study. But, so that's pip, and, you know, the same thing basically for dip, DIP, right? So that is the distal interphalangeal joints, and they can flex and extend as well, and I'm trying to do just those. Again, it's very difficult to not move both of those because they're controlled by similar muscles. So you can bend at the distal interphalangeal joint, which is between the distal phalanx and the middle phalanx of each digit. So, same concept. That's, you know, going over the same thing over and over again. It's probably, you got it by this point. So the last thing I'm going to mention is, you know, similar concept at the interphalangeal joint of the thumb. It can flex and extend. But the shape of those joints and the strength of the ligaments does not allow any other movement.